Hey guys, so just wanted to go over the 2025 FRQs for the CSA exam that the College Board released recently. And so, yeah, let's just get straight into it with problem one. This is your methods and control structures problem. And so we're dealing with two classes, and we want to implement two of the methods in the dog walker class. And so for part A, we want to implement the walk dogs method. And we need to utilize two methods from a different class called dog walk company. And for this method here, we want to return the number of dogs that need to be walked at the given hour. So hour is passed in as a parameter here. And to determine that number of dogs that need to be walked, we need to compare if the number of available dogs that need to be walked at the given hour exceeds the maximum number of dogs that the dog walker can walk. And so if that's the case, which is specified through this if statement here, we just need to notify the user, I guess, that we can only walk the maximum number of dogs and then return that number. Otherwise, if this is switched, so if number of available dogs is less than max dogs, then of course we can walk all of the dogs at that hour because it doesn't exceed the maximum amount. And so it's pretty much just this. We just need to replace this with number of the available dogs at that hour, making sure that we call the method correctly, as in we need to pass an hour as the parameter. So yeah, simple enough it seems. On to part B. This part wants you to calculate the total amount that the dog walker will receive from start hour to end hour. And so for each hour, we need to make sure that at that hour, if the hour is within 9 through 17, or if the amount of dogs that are to be walked at that hour is equal to the max dogs, then the walker gets a $3 bonus. If that's not the case, so if either of these are false, then he or she doesn't get that bonus. And so we do that for each hour within this range here, start hour through end hour, and then return that total amount. And so here, I use the for loop here. You can use a while loop if you intend to do so. That should look like this. So we initialize that variable for the while loop. And then if it's less than end hour, then the loop proceeds to run. And then here is, you just copy and paste this into this loop. But we also want to make sure, since we're using a while loop, that we increment the variable as well. Otherwise, you'd have an infinite loop. So yeah, that's part B. And that should have been problem one. I just happened to just go ahead and test the cases that they provide as part of the description. And so with that, I also implemented the dog walk company class. They don't implement that for you in this problem, but I just went ahead and did that just arbitrarily based off the description that they provided. So if you're interested, you can take a look. And so I ran this off screen. So it works perfectly fine if you want to go over this on your own. But for part A's test cases, here, let's just say at hour 1, 10 dogs need to be walked, but the dog walker's max is 4 dogs. And so since 4 is less than 10, that dog walker can only walk 4 dogs. So this should output 4. On the contrary, let's say at hour 2, 3 dogs need to be walked, and the dog walker's maximum is 4. So in this case, all 3 dogs can be walked since it doesn't exceed the maximum. All right, and so for part B, I just took the table here and did that test case. So this correlates or corresponds with this table here. So at hour 7, 3 dogs need to be walked. At hour 8, 2 dogs, and so on. And so in this case, with the dog walker's maximum being 3, this should output 59 as it says. And so if I run this, it should output what the output should look like. And so yeah, that should be problem 1. On to problem 2. All right, problem 2, this is your classes problem. So essentially we have to create this signed text class from scratch. So we need to implement the constructor as well as 2 other methods. And so first, the constructor should be pretty simple. We're only passing in 2 parameters, the first name and last name. So we need to make sure we need to implement the private instance variables. And then in the constructor, we need to match these parameters with the correct instance variables. So pretty simple. Now for the first method, we need to implement the getSignature method. It takes in no parameters. We just need to check if there is a first name associated with the object. And so if there's no first name, then we just need to return the last name. Otherwise, we need to concatenate the first letter of the first name with a dash, and then concatenate that with the last name. All right, so pretty simple enough again. Now for this last method, the addSignature method, this was a little bit tricky if you don't know your string methods or how to implement them. A parameter gets passed in this method, and this parameter might or might not contain the object signature. And so we need to check for that. So if the signature is not included in the parameter, which is indicated by this using the index of string method. So if that's the case, then we just need to return the parameter and then concatenate that signature at the end. And then if the signature is included within the parameter, but it happens at the beginning, we basically just need to move the signature from the beginning to the end. And so that gets implemented this way. And otherwise, if all else fails, then we just return the parameter unchanged. So in this case, the signature happens at the end of the parameter. So yeah, had to do a little bit of reading there and a little bit of comprehending the question. But again, I just implemented the test cases that they gave as part of the description or part of the document. And so if I run this file, then it should match up with the return, all of the return values that they gave. So yeah, so that was problem 2. On to problem 3. Okay, so for problem 3, this is your arrays/ArrayList question. In this case, we're focusing on the ArrayList. So the background is that we want to construct matches for a chess tournament. And so we need to implement the constructor and a method of the round class. And so for part A, we're constructing the constructor. We want to add all of the names in this given array of names to an array list of type competitor. And so here we want to make sure that we initialize this instance variable with a new array list of type competitor with the given syntax that Java uses for array lists, and then use a for loop to loop through the names and add a new instance of competitor with their name as well as their rank, making sure that we add a 1 to that rank, because remember, with arrays and array lists, they use 0 indexing. And so if we don't add a 1 here, it would just be the name and then 0, and then 1 and then 2, which we don't want, right, as we can see by their example. So adding a 1 will solve that problem for us. So that's the constructor for part A. Part B is building the build matches method. It returns a array list of type match. And so here we want to make sure that we initialize a variable of type match for the array list. And then here we want to create matches from the given competitor list that we already initialized through the constructor. Now, here we want to be careful for the number of competitors in that list. And the criteria after determining the number of competitors in that list is that if it's even, we want to rank, or we want to match up the best ranked person from that list with the worst ranked, and then so on and so forth throughout. And then for an odd number of competitors, we just want to ignore the best ranked one, and then as it says, the remaining competitors are paired according to the rule for an even number of competitors. And so you just need to separate these for loops, since we're going through the list of competitor lists, stopping halfway through because we're matching up the front of the array with the end of the array. And so at the midpoint is where all of the competitors should be matched up. So that is where that comes into play. For an even number of competitors, which is the normal way of matching up competitors, we just need to get the best ranked and then get the worst ranked, making sure that we index it correctly. And then we add that to the matches array list that we initialized originally. And then for an odd number of competitors, it's pretty much the same thing as the even number implementation. It's just that now we need to be careful with indexing, especially because we're just ignoring the best ranked one. We're not discarding it. And so the array list remains intact. We just need to be careful with the indexing that takes place when we're trying to get the competitors, when we're matching them up. And so yeah, that should be part B. And then of course we return matches at the end after all is said and done. And so here I tested what they gave from the document. So if I just run this real quick. So for part A, I just tested if we can just get the array list of competitors from the given array of players, which is here. And so we can see Alex, Ben, Kara, rank 1, 2, 3. Good to go. Now for the part B test. So we want to match up the an odd number of competitors as well as an even number of competitors. And so for the odd number of competitors, which can be shown here, Alex gets ignored and Ben and Kara just gets matched up. Pretty simple. Now for an even number of competitors, like they showed, Ray and Tim gets matched up and Sam and V gets matched up, which can be shown here. And now for this problem, I made my own test case just for fun. So I had another even number of competitors example, this time with 6 players. So just following this array, we have rank 1, 2, 3, 4, 5, 6. So in this case, Steve and Paul should get matched up, Mario and Logan, and then Yoshi and Jake. As you can see here, with the ranks shown, good to go. And then just an odd number of players. This time we have how many did I put? 9 players. So in this case, since there's an odd number, Abby gets ignored. And so we matched up. And so after that, we just matched them up normally. So Blake, Isaac, Charlie, Harry, Dara, Gretchen, and then Eden and Fox, as you can see here. So yeah, that should be good to go then. So that was problem 3. And now it's on to the last problem. Okay, so for problem 4, this is your 2D arrays problem. We are only dealing with one class here, the sum or same game class. And we just need to make the constructor and as well as a method for this class. And so for the constructor, we are just going to take in the number of rows and number of columns specified and making a new 2D array, a new instance of a 2D array. And then for each element within that 2D array, we want to initialize a random integer from 1 through 9, which can be implemented this way. And of course, with the double for loop to initialize each element within the 2D array. So that was for the constructor for part A. Part B is making a method that takes a row and column index, and that's going to give you access to the value in that 2D array. And what we want to do with that is try to clear that value with a second element in the 2D array. And we want to keep in mind with this second element that we can only clear the pair if the two elements are equal or they sum up to 10, and the row index of that second element is at or below the row of the first element. And so how I did this was the double for loop, of course, to try to access each element in the 2D array. But what I did was, this was giving me problems actually, because I did not take into account that when I'm trying to access each element in the 2D array, that the first element in question can be double counted. And so if I hadn't included this column not equal to j, sorry about that. Yeah, column not equal to j, this check for that, I'm forgetting the term, but if I hadn't included this, then the criteria where the two elements have equal values would become true. And so that first element would just be resetted to 0, which is not supposed to be the case because we're supposed to grab another different element in the 2D array. And so this was pretty critical to solving this problem so that none of the elements are double counted for. And so yeah, if statement, and then if that is true, then we want to just reset those numbers to be 0 and then return true since we did clear a pair. And then this other if statement just takes into account if the sum is 10. And that's under if we're at the first row of the given row index that was passed through. Once that is already passed, as in like we're going to the next row, then we don't need to include the column not equal to j check, because we're already past the first element in the first row. And it's essentially the same implementation as inside one of these if statements here. And so, and if we haven't returned true at this time after we checked all the elements, then we return false, of course. And so hopefully that made sense in terms of what I implemented. I'm going to go over a few of the test cases that were given, just to reiterate the implementation again. So if I just run this real quick. Some mercy B. Then we just go one by one. So the first one, we want to grab 7, which is row 0, column 1, which is 7, and this gets cleared with this 7 on the second row, right? And so that's true. The second one is false because this 1, or no, is it 1? Yeah, so the value is 1, and we can only check the rows from this row onwards. In this case, it's only this row here. And so there's no numbers that sum up to 10 with 1, and there's no other ones in this row. So that returns false. And then same idea for these last two ones, or these last two examples. Now, I want to get to test cases that I wrote, just so that I know that I implemented this correctly. So 1, 2, 3, 4. So starting from here, which is test case 5. So I wanted to check for 1, 1, which is 0, or no, which is 2, right? This is the original array. So I can only check for elements in this row or later, which is this row and this row. And remember the criteria, which is if any of the elements match with the given value, which is 2. In this case, we have another 2 right here, so it returns true and this gets cleared, right? Now I made another test case 6, which tries to access 1, 2, which is 5. So again, we can only access this row and this row. And in this case, both of the criteria for clearing a pair works, since we have a 5 and a 5 here, which is equal, and they also sum to 10. But we only care about one of the criteria being satisfied. So those get cleared and return true. Now, this last one was a big puzzle that I made. So 5 rows and 6 columns. And we want to check for, what did I do? Yeah, this one. So we want to access row 1, column 5, row 1, 0, 1, 0. So this one, whatever this was, I forgot, or was it this one? Oh, 6. It was 6. So again, we can only access this row and then these later rows as well, right? And again, we're trying to look for either a 6 or a 4, since 6 plus 4 equals 10. And so we find a 4 right here. And so we clear those and then return true. So it seems like this implementation works, and those are all the problems.